Hello. Today we are going to learn about solving for an angle if an equation has a linear combination of sine and cosine, and we're going to expand cosine of a minus b in order to solve different equations. Now, uh, yesterday, or last lesson, I should say, we learned how to deal with combining a cosine and sine when they're added or subtracted together into one single cosine. Now, today we're going to solve equations for theta when we have that situation. Now, the problem in this is if we want to solve for theta, we can't because there's two thetas. So we want to write this as one single cosine. And so if there's one cosine, then we can, and one theta, we can solve for it. Now, we learned in last lesson to do this, the 3 is associated with the x direction, the -7 is associated with the y direction, and so um, the hypotenuse here, which is not 9 squared, but 3 squared plus 7 squared equals c squared, or 9 plus 49. So that's 58. So the square root of 58 is going to be my hypotenuse, which is also going to be my new amplitude when I combine these into a single cosine. Now the value, the phase displacement on this single cosine is going to be this angle right here. So what we need to do is take the inverse tangent of -7/3 in order to find that angle. And that's -66.6, or -66.8. So we'd say minus a negative, which is plus 66.8. And now we have successfully converted this equation into a single cosine with a single theta. And now we can solve this for theta. So what we do is divide both sides by root 58. And so we have cosine of theta plus 66.8 is equal to this mess, 6 over root 58. Now what we need to do is take the inverse cosine. So we need to draw another right triangle where the adjacent side is 6, the hypotenuse is root 58, so it's going to be there and down there. And this, we're doing this in order to get rid of this cosine. So what I have to do is take the inverse cosine of 6 over root 58, and I have 38 degrees. So if this is 38 and this is 38, we could, now whenever we do this, we're splitting this into two equations. We have 38 degrees here, and we could say negative 38 degrees here. So we take our, what's in the center, our argument, theta plus 66.8, and set that equal to 38 plus 360k, and we could, the other side, we have that set up to negative 38 plus 360k. Now we just have to subtract 66.8 on both sides, and both sides over here, and then theta will be equal to 38 minus 66.8, gives us negative 28.8 plus 360k, and negative 38 minus 66.8 is negative 104.8 plus 360k. All right, so here we have our general solutions. Now let's go back and find the specific solutions between 0 and 360. Now neither of those two solutions there work very well for us because they're both below 360. But if I had take negative 28.8 and add 360, I have 331.2. If I take negative 104.8 and add 360, I get 255.2. And those values, if I add or subtract 360, that will be out of our desired range. So here are our specific solutions, and up here are our general solutions. Now here's one in radians. So let's try to do this in radians and see how that goes. First off, 5 to the left, because that's dealing with cosine, and 2 down is here. Now make sure your calculator is in radian mode. And I take the inverse tangent of 2 over 5, and this is 0.38. And if I add pi to that, this whole angle is 3.522 in radians. So if I take 2 squared plus 5 squared, that's 29. So if I square root it, that would be root 29 cosine x minus 3.522. And set that equal to 4. Now I did that kind of quick because if you didn't understand this, go back to the previous lesson, and we did a whole bunch of those. Um, so I didn't want to take too much time up with that. So now what we do is divide both sides by root 29. And now we draw another triangle where our cosine is 4 over root 29. And it's going to be these two triangles. So I take the inverse cosine of 4 over root 29. And I got 0.773, no, 0.733, sorry, or actually 34 if I rounded it. This would be negative 0.734. So let's divide this into those two sections. X minus 3.522 is equal to 0.734 plus 2 pi n. X minus 3.522 is equal to negative 0.734 plus 2 pi n. Now when we add our 3.522, x will equal, well, we have 6, 5 to 4.246, 56 plus 2 pi n. And now if I take negative 0.734 plus 3.522, I'm going to get 2.788. So x equals 2.788 plus 2 pi n. Now this one's easier because both of those values are within 0 and 2 pi. So our specific solutions are already there. All right, hopefully that makes sense on how to solve those equations. Now our next topic we're getting into is expanding cosine of 58 minus 20. Now a lot of people intuitively think we can uh, distribute over the parentheses and that would work. However, this is not equal, and I want to show you just using numbers what happens. So if I take the cosine of this, which is 38, the cosine of 38 degrees, I have to make sure my calculator's in radians now, is 0.788. Now we want to see, does this equal that cosine of 58 minus cosine of 20? Cosine of 58 is 0.5299, and cosine of 20 is 0.939. I should have a minus sign in here. If you subtract these two, that does not even come close. This would be a negative number. This is 0.788, so this does not work. So now we got to figure out, what does that equal? Well, on this page, let's break it down. We have cosine of 58, we already found out was 0.5299. Cosine of 20 was 0.9397. And now let's find the sine of 58, 0.848, sine of 20, 0.342. And now I usually ask my students, how does that equal this? Nobody knows. So we're going to take these two chunks and multiply. So I'm going to take those values, and I have 0.4967, and down below 0.848 times 0.342, 0.290. And usually at about this time, someone says, oh, those two we can add to get 0.78. And everyone's usually pretty excited, and they're like, now what does that mean? Well, if I have my first value is a, my second value is b, cosine of a minus b, what do I have to do? I have to take the cosine of my a value, multiply it by the cosine of my b value, and now I have to add that to the sine of my a value to the sine of my b value. So this is our equation. So just simple distribution doesn't work. You have to do cosine of the first value times cosine of the second value plus sine of the first times sine of the second. Now, we have a proof for this, and we're going to prove this in class. It's a rather long proof and probably not fit well for a video lesson. So let's go on to using these properties. So if I want to expand 4 cosine of theta minus 45, I would take the 4, put it out in parentheses, and expand cosine of theta minus 45. Remember, this is like a minus b. So I'll write out this equation, but instead of writing a, I'm going to write theta. Instead of writing b, I'm going to write 45. So it's cosine theta cosine 45 plus sine theta sine 45. And now, since we know the cosine and sine of 45 is root 2 over 2, that's like root 2 over 2 cosine theta plus root 2 over 2 sine of theta. And now if I distribute the 4 to both of these, 4 divided by 2 is 2. So this would be 2 root 2 cosine theta and 2 root 2 sine theta. Now one thing that's interesting is really what we're learning is how to do the opposite of what we did previously today and what we did yesterday. So this is a linear combination of sine and cosine. Um, Yesterday we were converting it into a single cosine, and now we're learning how to go back and check our work. All right, let's try this one. Now, if you think you can do this on your own, pause the video and then check to see if you're right. We'll take a 6 to the outside, and we'll expand this cosine theta cosine 70 plus sine theta sine 70. Now, on this one, we can't just find cosine of 70 on our own. We have to use our calculators. But I'd like to distribute this first. So I have 6 cosine theta cosine 70 plus 6 sine theta sine 70. And now I'm going to multiply 6 times cosine of 70 to get 2.05 cosine theta. 6 times the sine of 70 is 5.638. And there we go. That's our solution. Now we wrote this as a linear combination of cosine and sine. We have one more that just has something in front of the theta, but we do it just the same. This would still be a, this would still be b, so this would be cosine of 2 theta cosine 210 plus sine of 2 theta sine of 210. And then when I multiply it over, it'd be 5 cosine 2 theta cosine 210 plus 5 sine 2, this should be a theta, not a 20, sine of 210. So now I just take 5 cosine of 210 to get negative 4.33 cosine of 2 theta. and then 5 times the sine of 210 to get minus 2.5 sine of 2 theta. I should have a y equals maybe on there. All right, hopefully that makes sense to you, and hopefully you'll be able to do the homework.